So now I will just hand over to my friends from Draeger. It's a pleasure for me to introduce one more time to Oliver Bornholt. Oliver is part of Draeger Safety in Germany, and of course he has 25 years of experience in various industries, and in recent years has been actively developing new business models and launching new smart technologies and IT solutions. Um, Welcome, Oliver, and also Oliver Steinman. He's part of Draeger Safety in Germany as well. And for more than 15 years, he has been focusing on PPE solutions for different industry segments. And at Draeger, he oversees the steel market, looking for trends such as smart safety or energy transition in order to find the best suitable offering. So welcome, Team Draeger, and wish you luck. The floor is yours.
Yes, thank you, Carlos, for this information. And to both of you, Andrew and you, Carlos, thanks for this invitation. So it's a pleasure for us to be here. And also thanks to Stefano for this valuable presentation. And I promise you, you will find some of his statement in our presentation again. So in the next 60 to 70 minutes, we would like to invite you to have a deeper dive together with us into hydrogen properties, hydrogen safety challenges, and of course about detection technology as a special safety layer. If there are any questions coming up, please feel free to put it in the chat box, and we will do our very best to answer them. So you are warmly welcome to participate here as well. Before we will come to the first agenda point, we would like to briefly introduce ourselves, even if this has already been greatly done by Carlos, but some few words. And if you want to stay in contact with us also after this workshop today, please feel free to scan the QR code and you will get access to our LinkedIn profile to stay in touch. So I'm very happy that my colleague Oliver is with us today because he is our hydrogen expert. And yes, Oliver, so it would be great if you would add some words about you.
Yeah, thank you. Yeah, as you said, I think Carlos introduced a couple of words. Yeah, since roughly 2 years now, hydrogen is and the whole ecosystem is on our agenda. So I'm used really to assess new markets, and we are still learning a lot. And now, in cooperation with the World Steel Associations, where you can even look deeper into it. Why is this so important for us? Because we, and maybe as you as well as a company, looking into the future, into the next 10, 15, maybe 20 years, this may interrupt, let's say, a lot of really big economic eco chains. And this counts for us as well. And this is the reason why we're definitely looking into this very carefully, also with our board of management, technology-wise. So we are still learning. There will be applications that we cannot cover yet. So looking really into the future, having our, our glasses on and looking into this. So this is a reason why we are here. This is, let's say, our job, Oliver's and mine. So it's easy for you. You just have to remember one name. You will get always one. And really looking forward to get, let's say, your feedbacks also later in this workshop. So because then we can learn from each other. And this is the reason why we're here also for the next months to looking deeper into this. So thanks for this. Thanks for the opportunity to be here.
Yes, thank you, Oliver. And very briefly to myself. So I'm a part of Draeger for more than 10 years now. And as we are a customer-centric company, also our departments are focused on our main target group. And here, Oliver and me, we are both part of the marketing team of processing industries, and I, in this function, have a closer look on the steel industry. So that's my main purpose, and that's why I'm very happy to be here today. So as I said, I would like to introduce Draeger very briefly for those of you who don't know us yet. So we are a company founded in 1889, so a long history. We are situated in Lübeck, a very beautiful town in the north of Germany. Globally, near to 16,000 people are working for us, and we are achieving net sales of 3.3 billion euro or $3 billion roundabout. We are a family-run company in the 5th generation, and here Stefan Draeger is heading our companies for many years now. And beside Lübeck, Germany, we are present in a lot of countries with production sites and sales and service location, and rough overview you can see here. I would like just to underline that we are a very service and consultancy driven company, so that's why you will find a lot of sales and service locations around the world, because that's a clear focus of our company. Yeah, just to add some details regarding the figures. So you remember the 3.3 billion euro, and we have two main divisions, and you can see that the bigger part of our company is taking care about medical applications. So here you will find us in the operating room, in the emergency room with anesthesia machines, monitoring, and so on. And the other part, and that's where we are today talking about, it's a safety division. And here our main focus is on gas detection technology and breathing apparatus, just as a rough overview. 16,000 employees currently, and as I said, we have a strong focus on sales, service, consultancy, and that's why up to 60% of all those people are related to those functions. So what is motivating us day by day? And it's a very sad fact that every year 3,000 people are dying in workplace accidents, only in Europe. And we are sure that modern safety technology will help to reduce this number, and that's our big mission, to help our customers to gain the Vision Zero goal that might be also very present in your company. Yeah, a bit more in detail what is behind. So some of you will know us mainly from this part of our portfolio. For example, the main application is to detect CO2 in steel application with mobile devices or fixed gas detection systems. But you will perhaps also have some breathing devices from Draeger, from a FFP mask to SCBA for fire brigades, airline system, and also a very important part if you are detecting dangerous gases. there might also be a need to have a closer look on safety equipment. Some additional portfolio parts, body and head protection, and as a company having a focus on personal protective equipment, we also provide the technique you need for maintenance and repair. Yeah, it's getting more and more important. So the software solution related to all our products. And of course, as I said, it's not only the technical device we are focusing on, it's also a huge offering of services for different situations, for example, for shutdowns that our customers are realizing. We are helping with rental products, even with the safety stuff we bring in to make the shutdown to get a safe one. And the training part, and that's also why we are here today. Draeger has a global academy, because knowledge and training is, from our perspective, one of the biggest factor to mitigate risks. And that's why you will find a lot of initiatives of Draeger to build up this knowledge, and that's also why we got in touch with Carlos and his team. Okay, so now having said this, coming to the main topic for today, and this will be hydrogen. And for the next slide, I would like to hand over to Oliver again. Yeah, so Oliver, the stage is yours.
Yeah, thank you. So I try to take over the control. I hope this works now. Very good. Seems to work. Yeah,
Great.
thanks. Thanks for the handover. As you can see, within the next chapters, we go through some more deep dives, starting with, let's say, the ecosystem, the properties, some challenges, and deep dive roughly in some applications, explosion protection, risk management. Then hydrogen detection technologies, we'll get an overview. And then for sure, later on, questions and answers. Yeah, starting with that, I would love to give a rough overview how we currently see this, let's say, this overall picture in terms of where we see applications, and some of them will be important for you as well. It starts already what you can see here with, let's say, the power generation. We know from some steel companies that they will be or already doing producing their hydrogen on their own using renewable energies, talking then here about electrolyzers, and then using, let's say, this freshly produced green hydrogen as a feedstock. What you can see here, for example, for DRI or for blast furnaces or for other processes in your industry. The same counts as well for the, let's say, other CO2 consuming industries like fertilizers or cement or chemical industry. So this is not new for them. But at least what is new, really producing or setting up an hydrogen ecosystem, which comes then with, let's say, a lot of challenges as well. We, especially in steel, with a high demand of let's say, renewable hydrogen or renewable energy and green hydrogen, we have to talk about importing as well, and then we talk about high volumes as well. So this is where we are active currently, especially here on this area of usage in the mobility sector. Everyone has read the news when we talk about heavy trucks, even trains and planes. The aircrafts will use, and still in the situation of really getting this set up. Yeah, but where to start first? Hydrogen in the steel industry, we've heard this a bit already, also from Stefano. I will not deep dive into this because this is known to you, but this is exactly where this whole thing starts. And that means, really talking about some properties. Why is this so important? You have to know the stuff that you are using because this leads to some challenges and some behaviors. So let's be aware. Yeah, just let's say seeing here hydrogen, and we talk about the density, it's really 14 times lower than air. Also, if we talk about outdoor application, that means something. It has to do with a mixture as well, and with air dynamics. So that means, and we come later to this, how gases are dispersed in an environment. Also, if it's even outdoor, we have very hot environments, and the dynamics could be quite complicated. That means you need models who are really reflecting these kind of properties as well. Yeah, next thing is for sure molecule size. What does that mean? No, comparing just, for example, hydrogen to methane, that means here natural gas, it's 4 times lower roughly. When we talk about embrittlement, we talk about leakages, we talk about sealings. So this is controllable, but at least you have to know that it's not, let's say, a low-hanging fruit, just using another gas and then taking the assumption everything will be good. So it needs to be controlled. A very important fact is, let's say, the very, very low ignition energy. If you see this here, so we've talked about this. That means it's 15 times lower compared to methane. And then we need to take into consideration ignition sources. And let's say, and we come to this, the range, really the flammability limit from where a hydrogen mixture, volume by air, from 4 to 75%, it is explosible. And if it comes to that, the burning velocity is a lot higher. So that means a possible damage could be, it depends also on, let's say, the volume. It could be higher just to the speed of such a flame or such an explosion. Just to keep this in mind, it is not, there are some other specialties as well, especially for hydrogen, but I will come later to this. We have here some other properties as well, just an overview. When we talk about ignition energy compared to flame temperature, as you can, hydrogen is a very special gas. 99.9%, the most, let's say, important gas in the universe. Also the easiest one. It's just, just one electron, one proton, but it's a very special. It's like a diva in the universe. We see here really the highest flame, and the flame is even not visible. We come to that, and the ignition energy is very, very low. Yeah, another important fact is gas dispersion. This looks quite complicated, but it's not. So we see here, as you can see here, the explosive atmosphere in LEL, lower explosion limit. So that means here 4 volume percent, and then going up. So from 4 volume percent, this is the LEL. And when we look here, and this is a study that has been done already a couple of years ago, we see here just a height of from 0 ground to 2.4, but this could count for, let's say, for other environments as well. It doesn't have to be indoors. That could be also, that is something on top of it. That could be a tank, that could be something else. You see here the behavior from, let's say, this reddish to methane, that really quite fast you will come to an explosive atmosphere. So that means the early detection is even more important, especially here for hydrogen compared to other gases. Modeling can be done. So really gas dispersion analysis is something that we are doing as well for some applications, really taking into consideration what is your environment, what is your dynamics, what kind of heat sources you have, wind directions or whatever, so that at least you get a better understanding of what could be possible in terms of leakage. Yeah, having said this, I would like to hand back to my colleague and really taking the properties into consideration and then talking about some safety challenges that will come with it.
Yes, thank you, Oliver. And as we now are aware of some specialties of hydrogen, and I like the picture of the diva, we now take a step forwards to the safety challenge resulting from it. And to underline it, from our perspective, hydrogen is not an unsafe gas, but you just have to be aware about the challenges. So coming to the first point, and here we would like to underline that, of course, hydrogen is part of industrial production processes for many years now. But now during energy transition, it comes more and more into new application. And there are two aspects. First of all, people tend to mistrust hydrogen if it is a new one. And that's why knowledge is necessary to increase the acceptance of the people working now in hydrogen application, because everybody might have the picture of the Hindenburg Zeppelin in his mind and the big explosion related to it. That picture is in the mind of a lot of people, and that have to be changed. On the other hand, as we already said, the knowledge is key because you have to be aware of some safety challenges. And here I brought, here's the pointer, I brought a study from the European Hydrogen Safety Panel, and they did an analysis on some hydrogen incidences that happened in the past, and they found out that in many cases, 26% of those incidents, proper training and education would have prevented this incident. So here you can see education is key. Coming to the second point, it's permeation. And here we come back to the property Oliver was talking about, and Stefano as well. It's about the low density of the hydrogen molecule. And that's why hydrogen tends to permeate through materials, and under special conditions, as Stefano already explained, there might be an embrittlement on material. But yes, so hydrogen is transported and used for centuries now. So it's more a question of right choice, handling, and maintenance. And that's the part also Draeger is very aware of, because one of the first invention in the early foundation time, 1899 here, was a hydrogen oxygen machine. So yeah, so experience for many centuries now. Yeah, coming to point very close to the last one, it's leakages. So this is due to the small molecule size and the low viscosity. Here, very good point is that hydrogen is not toxic, but nevertheless very explosive, and that's why maintenance and plant inspection is very important. And here you will need a gas and leak detection technology because, and that's a part which will come up in a second, we can't smell hydrogen. Safety challenge for CO alarms, and CO is a very common gas in steel application. As we already heard today, the importance will decrease, but nevertheless, I guess CO will be still present in steel application in the future. But the sensors which are currently used to measure CO and to alarm the people who are in high CO concentration, there is an issue that these sensors have a cross sensitivity with hydrogen, and this may lead to false CO alarms. And that's why it is crucial point to use the right sensor technologies, because there are sensors who have hydrogen compensation but this has to consider when you are dealing with hydrogen and CO in your application. Safety challenge number 5, gas pockets. And yes, we are aware about the low density and of hydrogen, and hydrogen is of course less dense than air, so it will tend to get up in the air. For outdoor application, that might be not so critical. Even you also have to consider some outdoor weather condition who can also cause some issues here, but mainly for indoor, there might be the risk that there are gas pockets. For example, in compressor rooms, in filling station, in electrolyzers, and here it's very important to know where to place sensors, where to have to take into consideration the streams, and you might also need some ventilation. Anyway, you have to make sure that before entering a room, you have to make sure that the concentration of hydrogen is below the lower explosion rate, and that's an important part. Safety challenge number 6, no odor. Yeah, you can't see it, you can't smell it, you can't taste it. And you might say, yes, but we know this from natural gas, and here it's not a bigger issue because we have some odorant added to the gas, so it's smellable again. And yes, there are currently some studies having a closer look on this topic, but here again, the problem is the small molecular size of hydrogen, because the size of the odorant gas will be much higher. And then the question is about mixing rate. And so that's not an easy one. So, and that's not clarified. So at the moment, still we have to say, yes, no odor for hydrogen. And that's why you have to take care about leakages. You have to monitor gases to have an explosive atmosphere. The invisible flame, yes. So good news from a flame of hydrogen. There is not so much heat emitted like from other flames, so the risk is lower. But nevertheless, if you can't see it, and open flame is always a risk in your production. So you might think about flame detection that, from our point of view, would be necessary then. And we will also come to the sensor technology as a solution later on in our presentation. Number 8, and this is also related to sensor technology, because in many cases the technology of infrared is used to detect gases, to get aware of explosive atmosphere. And this is an issue for hydrogen. Because of its properties, it is invisible for this sensor technologies, and that's why here you have to be aware of this fact and should more go to CADEX sensors instead. If you have a methane blended, you can you also have to take some special things into consideration. But yeah, that's a fact. Hydrogen is invisible for infrared sensor technology. Yes, a big threat is X protection, because yeah, you have to be aware that the energy to ignite hydrogen is 14 times lower than methane, as Oliver already showed in his part. And that's why you have to take care about X protection. That would mean every device you are using, every material must be suitable, must be certified, depending on the different X areas. We will also tackle this topic in a moment. And to point it out, the classification tends to get stricter here. You will also have some discussion perhaps with your assurance company, who will also have some questions about your safety plan getting into hydrogen application, and also public authorities will want to have a clear safety plan, talking about operating licenses and so on. Yeah, last but not least, safety challenge number 10, it's about ignition. And here you have to be aware that under certain circumstances, hydrogen might self-ignite. This is also relevant for high pressure applications, but nevertheless, as I already said, the ignition the energy you need to ignite hydrogen is low, and perhaps electrostatic discharge is already enough to ignite hydrogen and to cause an explosion here. Here, solution is, of course, flame detection on the one hand, but a very powerful technology here is ultrasonic leak detection. And here again, Oliver will come back later to this. Yeah, just to sum it up, so hydrogen is entering more and more applications, and yeah, it's a special gas. It's not a special dangerous gas, but it's a special gas, and that's why we would like to underline knowledge and education is key, and that's why we are happy to be here today and discuss with you later on. And now I would like to hand over back to Oliver, and in the next step, he would like to give some insights to applications from our perspective and give some insights here.
Yeah, thanks so far. A lot of information to digest. As we said, in the meantime, if you have questions that will pop up in your mind, just put it in the chat window or keep it maybe on a piece of paper for later discussion, so that nothing will be getting lost. Applications. I will give you an example that is also a bit comparable of maybe what you are doing. There's a risk potential of, here is an H2 filling station. H2 filling station means, and we have here an example, what happened is in so far comparable that you have a big storage facility as well, compressor facilities in each of these filling stations. And it's just 3 years ago, 3 years ago, where a big explosion in Norway happened. You can ask, okay, what happened there? Why couldn't it be avoided? So within the Center of Hydrogen Safety, there are several working groups really looking deeper into that. And some of the findings were, this happened unfortunately often, really, I think, a human failure. During maintenance, there was just one screw out of these big tanks after maintenance that were not fully pulled, and that really led to this disastrous explosion. They got a high leakage rate, and due to that fact, and here's another diva property of hydrogen, it was self-ignition happened, or can happen. And this counts to the so-called Joule-Thomson effect. So everyone, or maybe you know the Joule-Thomson effect also at home. If you have, for example, a spray bottle and you spray, it's normally getting cooler due to this Joule-Thomson effect. So it means really the expansion of the gas takes off heat, and there's a reason why, you know, it's cooled down. Not with hydrogen, not with hydrogen when you have high pressures. Then you have a so-called negative Joule-Thomson effect. And that means if you have a high-pressured hydrogen and you have a leak, maybe with a high leakage leak rate, it's getting hotter. And that means due to a certain temperature, it can self-ignite. So this is really a special thing. Yesterday, I got the notice that especially these gases in your environments are getting heated up during the gas heater process, up to several hundreds degrees Celsius. The self-igniting temperature of hydrogen is, I think, 580 degrees Celsius. So that means, you know, if you're still below and then you have a high leakage rate, it can easily be burned or it can be explode. If you have a leakage after a gas heater, then immediately it would burn. So that means flame detection and leak detection is here really crucial to take safety measures. And it's still under investigation. It's not finalized. What if, let's say, leak detection were in place, and what happened? But it was really a disastrous example. You have some other applications that maybe not interesting for you, but which keeps us quite busy. For example, service and maintenance facilities. Here you see buses, or it could be trucks. As well, these are areas that are normally not used to handle hydrogen, and this is a reason why you really have to look into regulations. What is really needed? Something is not regulated still, so there are a lot of working groups in IEC and in other regulatory groups who are really looking into this and setting this up. And for sure, you need to talk about trainings, emergency plans as well, but this counts on your side as well. Yeah, when we talk about a DRI facility, for example, you need really to analyze, and maybe you did this already if you have this in place, where do I have my storage? How do I transport my compressed or even liquefied hydrogen to the place where it's really needed? Is a safety concept really in place if something happens? So that means you need a proper risk management process in place. Do I have leak and flame detection in place? And if yes, where? So taking into consideration gas dispersion, what I've mentioned before. Are there ceiling areas? Are there shaded areas? What about wind and maybe heated components? So there, maybe I have really a complicated air and gas dynamics. And is the personnel, including contractors, trained in case of an alarm and of an incident? So that means, as I said, the correct placement of sensors is critical to safety. So that means, here's just an example. It could be, and due to, let's say, the whole dynamics, maybe this is not the best example, but this is exactly what is needed to be done. This is not one size fits all, so that I would know, or maybe our specialist would know, if I talk about DRI, then the places sensors need to be placed here and there exactly. Environmental considerations need to be taken into account. This is the reason why normally, let's say, an on-site assessment is critical here, because the gas needs to come to the sensor. If you have a leakage somewhere, and with, let's say, the hydrogen gas dynamics that we have seen, it is really crucial to check, is it possible that an amount of gas really can come close to the sensor? If not, then the best sensor technology will not help you and save you. Yeah, as I said, gas dispersion is really, I think, let's say, main topic. Especially hydrogen air mixtures with low hydrogen amount is totally different to high hydrogen mixture rates, also in terms of the gas dynamics that I have. So that means the leakage Hates level really plays a significant role in, let's say, this modeling, but I've showed this graph before. Yeah, having known this, we for sure we need to look a little bit deeper into explosion protection in some regulations and some standards. Why we need to do this? Some of these standards are already and since years available, especially when we talk about ATEX directives. There is for sure some minimum requirements for improving the safety and the health already available. But let's say the hydrogen industrialization that brought, let's say, so many new questions to these, especially to this mandatory, for example, IEC and FPA codes, that it's still under investigation. Still, we have some pilot plans in place where the outcome will for sure influence, let's say, these working groups. In some of these working groups, we are also active, especially when we talk about gas detection, gas dispersion, safety, also, let's say, personal and asset protection is part of that. So this is something where for sure you or the groups or the World Health, what Carlos mentioned, can help you a lot. Because this is really tremendous, a lot of material. But yeah, I think within, let's say, this big initiative here, we will come closer to that and can help you also with finding then the right and the correct chapters. Because we all have a duty in our personal lives and our working lives as well to protect health and life. For example, we have really basic laws. We have laws, legislative laws, also from the EU, from other continents. So we are not here only with, let's say, colleagues from Europe. We are colleagues here from as far as from India as well, and some other countries. Yeah, we really have to look deeper into this. Most of them are really legally binding. So if you're going into operations, you have to have them in place because they are checked. Some other ones for sure, ISO norms, technical rules, some principles, sometimes only government action plans, like, or other big plans like we have a Vision Zero, for example. These are state of the art. This will help you also in terms of what Stefano mentioned, really help you to change and to develop your safety culture. And this is especially for hydrogen a very crucial and very important topic. How can you assess explosion control? It's just, let's say, an easy example here. Are flammable substances present? If no, then also from the regulatory part, no explosion protection measures required. You can document this in your risk assessment. If yes, can an explosive atmosphere be created? If no, same answer, then you are safe. If yes, if you cannot avoid it or can exclude it, you really have to estimate and quantify as well the explosive atmosphere, considering some properties, tightness, natural ventilation, as I said, gas dispersion in this environment, and maybe some organizational specifications that you have already in place. So this needs to be really done within your risk assessment. Is then, let's say, the occurrence of these explosive atmosphere, can this be prevented? Taking into account maybe protective measures that you've maybe done already. Also, this needs to be taken into consideration. If yes, fine, same answer. You need to document this because you are fine only with the protective measures that you maybe have already in place. If not, then you need really an explosion protection concept. You need a proper documentation, and you need then a testing obligation as well at the end. And this is mandatory. Explosion protection, what does that mean? We talk always about the lower explosive limit, the LEL, and an upper explosion limit. We discussed already the ignition temperature and minimum ignition energy. All this information you will find, in these ATEX abbreviations used for all components, sensors, or whatever that needs to be operated in explosive atmospheres. You will get this information. May you know this already. But here you can find the real, let's say, the real specifications for it. Also, our sensors or the equipment that we are providing are fully ATEX conform, also for hydrogen. So that means, just to be careful with it. Also, for what kind of gases is it used for, or is it, let's say, tested against? So this is also quite important here. Yeah, what regulations? The take-home message is what? The regulations are really extensive, but as Carlos said, we can guide you through this process, especially through, let's say, the hydrogen-specific regulations. You definitely, and this is a local task, you have to determine the explosion hazard. So what can happen? What do I have on site in terms of storage, in terms of transport, pipes, compressors? So this is maybe new for you, maybe not, but definitely it needs to be documented. You need a hierarchy of measures. We will come to that: primary, secondary, tertiary. This comes in a couple of minutes. The equipment we've discussed needs to be ATEX certified. You need to document this in a really proper way. Also, may you know this, but and you're fine with that in terms of the occupational safety as well. You need evacuation plans, emergency management. Really, I think also from top of your management, so that everyone knows exactly what to do if it comes, let's say, to an urgent situation, let's say a severe situation. And we touch this: instruction and training. Education. This is really a crucial part. So we see this really in a lot of discussions with customers, starting with some basics, but then really discussing, okay, what is really needed? What is gas dispersion? Why is hydrogen maybe a little bit different to be handled as other gases? What about gas mixtures? Here we talk about also natural gas and hydrogen, sometimes mixtures. So what does that mean in terms of material selection and whatever? So there's a lot to learn, a lot to digest, and a lot to document. Yeah, as I said, there are 3 levels of explosion protection. The first level, the so-called primary, is really to prevent an explosive atmosphere. How to do that? For sure, to prevent the gases to leak. So that really, we talk about gas-tight construction. Normally, for sure, materials available, ceilings available, valves available, handling this. So this is really not new. But mainly for when we talk about maintenance, and this needs to be done for these kind of installations as well. So that means here as well, taking care about that. Most, let's say, most accidents around that happened while or after, or let's say, not proper maintenance were part of this. Yeah, prevent explosive atmospheres means as well, you need to take care that you can remove gas quickly if you have a leak. That could be a ventilation system. This could be a gas dispersion analysis, so that you really can take care or can save and can prove that if you have a leak, that it will be under the LEL, the 4 volume percent. So this needs to be really to be quantified. Then I would say you are on a safer side, not on the safe side, but on a safer side, in combination with a gas detection device. For sure, you can check, okay, here is something, I have a leak, but it's still under control and it's ventilated. So then you can take measures really to control this whole situation. And for sure, and this counts to the primary explosion protection level, gas detection, which is mandatory as well. Yeah, the secondary is to prevent ignition sources. Carlos and also Stefano mentioned this. X-certified equipment, grounding, mechanical, if possible, instead of electrical equipment. This is part of preventing ignition. Last but not least, the tertiary is referred as constructive as well, is really to prevent and reduce the damage if it comes to a fire or to an explosion, to lower really the effect. That means fireproof or retardant materials, but this is something that you are well known. I know this, especially in the industry. Pressure relief valves, mark ways for evacuation, that could be really something constructive. Conclusion, why is this important? When we are here, for sure, you need to prevent an explosive atmosphere in the beginning, really, going back to the root. And gas detection is definitely, let's say, the key technology. Yeah, risk management. May you have groups who handle this for you in your company. Yeah, what needs to be done. You need to identify the risk. You have to analyze them, and you have to evaluate the measures, especially the consequences, included then some modes of actions. For sure, you have an indoor or outdoor leak. This is an example for an indoor, but it doesn't matter. Immediate ignition maybe could happen, then for sure you would have an explosion or on fire. If no immediate ignition, then what happened then? Two things can happen. Hydrogen accumulation above 4 volume percent or even below. If it's, as you can see, if it's above, if certain things can happen, asphyxiation, potential of a pressure peaking, or you have maybe a delayed ignition in a layer. So this can happen as well for both. So it really depends on, do I have oxygen around and do I have an ignition source? So that means you have really to understand the mode of action and the consequences, and this needs to be documented in your risk identification and your risk management process. What you can use and what is mostly used to understand this is really, and I have this example of the hierarchy of controls. So first of all, you could eliminate the hazard. Not easy, because you want to use hydrogen, and that is currently not very helpful here. To substitute as well, hydrogen substitution with another gas which is maybe has a lower potential of risk, also not possible. So that means the next level is really the engineering control. That means you need to isolate the people from the hazard, and gas detection, plant fire protection, technical safety, ventilation is really part of it, and this needs to be documented. Yeah, next step is administrative controls, change the way people work. So that means you have a proper safety matrix. You have to have, for example, emergency stop of electrical equipment, emergency shutdown, permitted activities, what needs to be done, or blowing off of hydrogen, or a pressure, let's say, relief if you have a leak and you have a tank storage somewhere, so that you let's say, in a controlled process, lowering the pressure and boiling off the hydrogen, blowing off the hydrogen. Yeah, last but not least, PPE, personal protective equipment. This is for sure. When we talk about ESD equipment as well, and for sure, instruction and training is part of that. Risk, yeah, how does a risk assessment look like? So what is normally needs to be done? You're really looking into your working procedures that you have. You need to document them very carefully. You're really looking into a kind of what is the severity of a damage, what can happen, what is the probability. You rank them. You look here really in a kind of matrix, looking in so-called, and we use this from time to time, so-called IPL layers, independent protection layers. And if you have them installed, that could be technically, that could be organizational, you really lower your risk by IPL level. And then at the end, for sure, you have to accept a certain risk, which needs to be documented as well in this assessment. Then for sure, you need to evaluate, you need to validate your controls, and you have to check if your safety measures are really operating in a way that you are that how you defined it. This needs to be proved as well. And last but not least, education, training. Here, emergency escape training, including all the equipment that you have defined. That could be here evacuation of people out of these areas. Management needs to be trained as well in terms of, let's say, escape scenarios, in terms of bigger scenarios, including maybe if you have a local fire protection guard or a public one, so they need to be part of this process as well. All this can be done in a risk management workshop. So either, guys from World Health, or maybe we from Draeger, or maybe you have own guys who can do this, can perform these kind of workshops. We have also specialists who can help you with this. Sometimes it's good to have an external view on this process. We know this as well. So also our safety consultants that we have, I know some of them very well. If they coming with me, sometimes I'm traveling with them. They have a so different view on daily lives.
Sordum yok dedi, yedim. Mentolü dedim.
Sorry about that, Oliver.
No problem.
Could you please mute yourselves?
Yeah.
I think, yeah.
I'm muted.
That's fine.
I'm muted.
I think that's fine.
No, yeah, and this is something where I have already big learnings. Really to have, let's say, a third pair of eyes looking in these processes. That helps a lot. So this is part of our offering as well. And in general, you find engineering offices as well, which can help you with that. Yeah. Having said this, I will go to the summary here. Safety and emergency management within, let's say, Draeger safety. So what we are doing, as I said, we do education exercises as well. We can do risk analysis and define with you together protection goals.
For sure, part of this is then really C-level management board, alarm, emergency planning, crisis management could be part of that, and for sure then Propi's safety management system. So conclusion, and this counts for you, you need to have a holistic safety management concept, and this really plays the major role in risk mitigation. Yeah, coming now to, let's say, the primary explosion protection level, and here we talk about some hydrogen detection technologies. Normally I have a kind of comparison when we talk about sensing technologies. Yeah, looking into your face, you have in your head, you have 3 important senses: your eyes, you have a point detector as well, your nose. For some gases, it works very well. For example, methane, which is normally with some sulfuric odors, or even some sulfates. This is very sensitive to that. Or you could hear a leak. Unfortunately, our ear is not capable to do this because leaks, high pressure leaks from 2 bars above will emit acoustic noise in a wave in a wavelength, I would say, an acoustic range that we cannot hear above 20 kilohertz. So, and due to that fact, we have to trust technology. And that could be here an open path gas detector, that could be a flame detector and a gas camera, which can detect hydrocarbons in general. Point detectors, and we will come to that in a minute, will help you. Or here, UGLD is ultrasonic gas leak detection device, which will already hear what is going on in your environment. So why is this so important? We can talk about an event tree for gas release. So starting here on left, so you have here a gas release. So you have a leakage. 2 things can happen. I can have an immediate ignition. That can happen either I have an ignition source, or what we've mentioned is self-ignition if it's above 575 degrees Celsius. What happens then? For sure, I get a jet fire. If not, 2 things can happen. If I don't have an immediate ignition, I have a vapor cloud could form and could ignite. If it's an ignition, 2 things can happen. Explosion, I have a vapor cloud explosion, or I have a flash fire. If I, don't have an ignition immediately, or it ignites immediately, I can have a pool fire as well. So what needs to be done in this? So I can concentrate here on the vapor cloud. So I have a gas release, and I need to check, let's say, the LEL level. And for sure here, point and open gas detection plays a major role, really to prevent then the ignition and the ignition volume, the so-called LEL, the lower explosion limit. Even better would be if we said, okay, what if I start earlier? So if I have a gas release already, so that I could hear them. So the gas has not, let's say, to come to the sensor. And this is a really big advantage because especially in outdoor environments where you have weather conditions, maybe wind or maybe gas dynamics, heating furnaces that you have, where it's maybe could be complicated that the gas is really can be exposed to the sensor. Then it's definitely the better choice to rely on an ultrasonic gas leak detection. A big advantage is that background noise, it doesn't depend how loud it is, it's totally cut off. So it has a kind of band filter in. It really looks to, let's say, the footprint, really the fingerprint of, let's say, a leakage noise radiation profile. So it's really trained on it, and it's a proven technology. And this would be, let's say, the preferred choice here, really to prevent a vapor cloud already. So starting very early. Yeah, how will this look like? Gas detectors or gas monitors, gas cameras, as I said, are critical components and safety equipment, really used to protect lives and your properties. And using the sensor technology and gas detectors will measure and display the concentrations as well. So that means you know exactly and can document, you can have readouts, you can have dashboards where you see, is everything okay? And then also you can go back in time. You can just, okay, is there a difference day over daytimes, over shifts? All these things can happen, and that gives you a lot more information in your operation if something is going on. Yeah, and as I said, placement of sensors, where, in what application, where is it useful, not to over-specify, what kind of detectors? Is it a point detector? Is it maybe a multi-gas detector? Do I detect not only hydrogen, maybe other gases as well? CO plays a major role, and we said, okay, hydrogen in combination with carbon monoxide is a tricky thing, because most gas detection suppliers have difficulties with that due to the cross sensitivity of hydrogen to carbon monoxide. So that means that could happen that you have either a carbon monoxide level and then you get a warning that there is a possible hydrogen leak, or vice versa. So it means you definitely have to have a sensor that is cross-calibrated and can be used in these environments to avoid these wrong alarms. Luckily, we have sensors which can be used in these environments and are cross-sensitive to carbon monoxide and hydrogen. Having said this, flame detection is part of it and should be used. And now, some more deep dives, especially what I said here in these tricky environments. You need to take maybe you need personal monitoring as well, and multi-gases. Yeah, let's talk about technology. And this counts not only for this application, this counts now also for your environments. When we talk, for example, a so-called CADEX or Pallister sensor. May you have heard the name catalytic bead. This is, let's say, a same term that employs a catalyst and that prompts to a flammable gas. So that means the gas is entering the sensor. The gas in the sensor will be ignited, and then I get a temperature difference. When this combustion really occurs in the sensor, there's a proportional amount of heat produced to match the amount of the flammable gas. And this, leads then to the type of gas and the concentration of gas that I have within this environment. So these Pallister sensors, can generally be utilized as a generic catch-all, let's say, all in for all flammable gas detection technologies, and will respond from 0 to 100% LEL. So for hydrogen, for example, from 4% of hydrogen, which is potentially explosive, and this would be then correspond to a 100% LEL. So normally you will detect this earlier. So that means the ideal method below the flammable range of hydrogen would there then responding to a leak, and before an atmosphere reaches the potential explosive level. Yeah, another thing is the so-called thermal conductivity, what you see here. A Pallister measures the flammable gas as well, but they cannot be used to measure levels of gas above the LEL. Since the reducing level of oxygen will reside in a reduction of the signal. So that means, you really need to take care what kind of technology can be used. What do I expect in terms of a leakage? It's part of the risk assessment as well. So that means you need to be careful what kind of sensors are useful, can be used, or needs to be combined as well due to this, let's say, increased range, careful attention needs to be set it, also in terms of what kind of alarm levels, A1, A2, what kind of LELs do I expect? Do I have other gases around as well? It could be not even hydrogen, methane, so I mean natural gas as well, or other gases. So that means really, I think the choice of the hydrogen leak detection is really really crucial here. Yeah, looking deeper into that, let's say electrochemical sensors are another choice. How does that work? An electrochemical sensor really reacts to the target gas, for example here hydrogen, using an electrolyte which generate, when it comes into contact with the gas, a current that is then proportional to the amount of gas that is detected. This method enables, let's say, a more sensitive hydrogen gas detection than of a pellister sensor, and it can be used for multiple gases as well in parallel. So that means the disadvantage here is it's also pro and con is of this sensitivity is that an electrical chemical sensor can be damaged as well if they are exposed to the target gas levels exceeding really the measurement range. So that means it is so-called toxinization of these sensors. So yeah, which in plus comes always a minus as well. They are very, very sensitive. It's really for sniffing really around. So very, very sensitive, can go very low. But if I would have maybe a really high concentration, which normally not happens for hydrogen, either I have really, let's say, a big leakage or big concentrations around, then it could be critical. Yeah, both is available either for fixed gas installation or for mobile as well. And it's really ideal for ppm monitoring, really parts per million monitoring of hydrogen, providing really a very early warning of low level leaks well before they reaches a flammable range. Yeah, last but not least, metal oxide sensors. This is really a sensor type based on semiconductors. So here the hydrogen gas molecules interact with a film of metal oxide material on the surface, which is then a kind of chemical reaction. And then this reaction is directly transferred in a kind of electrical signal. It's long life, very stable, but non-selective, and may react to other gases as well. So this is a reason why, especially here, we would not recommend to look for metal oxide because then you definitely, or maybe in combination, definitely have to look closer into that. Yeah, last but not least, talking about flame detection. Here are also several technologies that can be used. In a flame fueled by, let's say, a hydrocarbon source, normally carbon dioxide, carbon, water, and heat are emitted. And here are several technologies that can be used. For example, IR. So since, let's say, an hydrocarbon-based fire is a strong emitter of an infrared spectrum, so you can really feel it. Everyone, feel it also with your skin. Single and maybe dual IR detectors are suitable for the detection. However, they rely upon a CO2 spike created by this hydrocarbon fire. And not all fires are the same. And unfortunately, a hydrogen fire, a hydrogen flame, will not emit CO2. So that means IR is not suitable here. IR flame detection. So then we have ultraviolet. Unlike hydrocarbon flames, hydrogen flames radiate really primary ultraviolet radiation. And then you will see them in some water bands, because if you have a hydrogen fire, water will be the result of it, water dust. Since hydrogen flames radiate energy, mainly in the UV band. UV flame detector is really the fast detection here for flames. We talk here about milliseconds. That can be, let's say, the detection time. So it's very, very fast. The availability also on the range of the distance is quite good here. So that means, on the other hand, as I said, always a plus and a minus. UV flame detectors are sensitive as well to arcs, to sparks, sometimes to sunlight, to welding, or to other UV-rich non-flame sources. So that means also these, if you have a UV emitter around, that could be a false alarm as well. So, as I said, always a plus and minus. So that means a UV detector is for sure the best, let's say, best technology, but best suited for locations isolated from these false alarm. Could be in closed room, compressor stations, electrolyzer housings, so even where you normally have no exposure to these other radiation sources. So then, now, as you can see, it gets closer and closer. We have UV-IR combination. The detector exists that utilizes both ultraviolet and infrared technologies in one. And these detectors require both UV and IR signals. It both need to be present for an alarm. So it is not an OR combination, it's an AND combination. And this is for sure offers a better false alarm rejection capability compared to just a UV detection. Then last but not least, this here is so-called multi-spectrum IR. But for this sensing both kinds of fires, UV, UV-IR, and let's say single and dual band IR detectors are being displaced by a multi-spectrum IR or triple IR detection technologies. And they really offer a better performance, fewer false alarms, and often lower cost of coverage compared, let's say, to a combination here of other sensors. So having said this, make a long story short, we have IR, as I said, it really goes for a CO2 spike, which will not happen with a hydrogen fire. UV, yes, is capable for hydrogen fires, has a good range, it's a fast response, as I said, within milliseconds, but we need to look into the false alarms, and we need to avoid these sources here. Could be an indoor application or an area where I can avoid other UV sources. Then I have the so-called combination UV-IR, which is definitely a very good choice, has a bit slower response than UV alone. But here we talk about also then, let's say, a second or so compared to some milliseconds, which is fine so far. Has definitely a better false alarm rejection and can be used for indoor and outdoor. And then last but not least, the so-called multi-spectrum can be used for HR fires as well, because it is a combination, has for sure a little bit slower response than for UV, but has definitely the highest immunity to false alarms, and it's also for both for indoor and outdoor. Summary, that would be the best choice here, or a combination of some sensors. It really depends on your environment, what you want to see, what is really capable, because we need a line of sight where you could have a possible leak and a fire. This needs really to be investigated. Yeah, here's my one of the best hidden secrets, an ultrasonic gas leak detector. So what does this guy do? These guys are detecting the acoustic emission created by a pressured gas that expands to a lower pressure. So there's a pressure difference. And this creates a certain sound. And there's an acoustic sensor like a microphone that really detects the changes and cuts out also the total background noise. So that means these are really mainly used for remote sensing in outdoor environments where weather conditions can easily dissipate escaping gas before allowing to reach, let's say, a certain level. Because with, let's say, when we talk about point gas detectors, which we've discussed already, the gas needs to come to the detector. As we said, gas dispersion, it really depends on where the sensors are placed. In combination with an ultrasonic detector, which hears already a leak from, let's say, 2 bars upwards, that would be the safest way. And as I said, we can exclude the, let's say, the environmental noise that I have also, let's say, in your environments as well. So ideally, using around, let's say, compressor stations where you have heating devices, metering stations, for example. Maybe you have gas turbine power plants there as well, or other facilities, you know, that contain hydrogen stored or delivered really under pressure. And then this guy here is definitely a preferred choice, this technology. Yeah, so having said this, the conclusion, the right gas detection technology is crucial, especially the placement and what is really needed where. So that, as you can see, that needs some knowledge, and we're happy to discuss later. We can deep dive in each of the technologies. We can look into applications as well. We can talk about really, let's say, scenarios later. But this is something what we want to discuss within this workshop later, and find out where you are currently in terms of your safety environment. Good. So I will hand back to my colleague, Oliver.
Yes, thank you, Oliver. Yeah, it took us even some minutes more than last time, but I hope that we provided some valuable information for you. Last slide, and this is only the last the summary for our part. As we heard today several times, from our perspective, knowledge and education is key, and we will have a discussion on this in our workshop in the following one. Of course, you have to be aware of the characteristics of the gases and the gas mixtures involved. I think we discussed it a lot today. Gas detection is an important safety factor to prevent explosive atmosphere, and there should be the right detection at the right place to prevent incidents. And of course, in total, dealing with hydrogen, but not only dealing with hydrogen, you need holistic safety management from our point of view, like Oliver showed today. Yeah, so from our part, that's all for the moment. Now there are some minutes left for questions, if there are any.
Yes, I think Malay, you raise your hand.
Great.
Yeah. So I hope I'm audible.
Yes,
Yeah.
yes, all good.
Yeah. So I mean, obviously, we got a good sense of information on what kind of sensor we should use and what kind of applications. So just one final question. Let's say if the area is spreaded, let's say it's a huge plant. So at what strategic location we will place these sensors? I mean, let's say leak detector or fire sensing alarms. So do we need to put these in multiple locations, or in a single location it can, because of its spread, it can sense most of the things?
Yeah. Yeah, let me answer this. I think this needs to be really done by a kind of, let's say, this is a normal routine work, kind of site assessment, So we definitely have to look into your, as I said, into your environment. So where do we have and identify together a possible risk in terms of leakages? So this needs to be done in the first step. And then we propose normally with our customers together how to place where, because over specifying things, it's also a matter of cost. It's not, let's say, something that we and that you want to do, but yeah, for sure, it's part of the risk assessment. It's part of, let's say, a gas dispersion, and it could be a qualitative gas dispersion analysis as well. Sometimes you can use dust or whatever, so that and smokes, that you see, okay, what kind of dynamics do I have here, and then placing sensors. That could be also that within working this out, and maybe you change environments as well, that you can replace sensors later. Is it okay? Here it doesn't make sense. You may have, in addition, mobile sensors with you. This is what we recommend, as I said. We're looking really to lower ppms and can do assessments on your own as well. So this is what we do from time to time as well. So we use our sensors, doing with you site assessments, walking around on different levels, doing low ppm measurements, and say, okay, what is going on here? What kind of gases do I expect? And then assess with you, let's say, the best locations for these kind of detectors.
Yeah, okay, thanks. So maybe I hope you have got your Indian counterpart. So maybe, I will connect with him, and then we can have a site visit, and based on that, we can have something. I mean, some
No
more
problem.
detailed.
So we have, we have specialist group in India as well, who are very much capable to help you really on site.
Yeah. So feel free to contact us, and we will reach out to our colleagues to get you connected.
Okay. Thanks. Okay,
yeah.
Bye.
Okay.
Thank you, Malay. Are there any more questions from the group?
It's Darren here, Carlos.
Hi, Darren.
Rather than put my hand up, I just wanted to ask, I guess it was good to see there's some different technologies there for detection, and I think you laid out well, you got to have the right device for the application you want to use. But I was just interested a little bit, are they significantly different in terms of being able to maintain or calibrate, or are they all sort of similar? That doesn't really factor into your decisions?
Yeah, I think maintenance and calibration is have to be part of, let's say, these sensor installations, which are done either by service personnel, or we have sensors who can, let's say, managed and maintained on a regular basis, let's say, with our control systems, which are under your control then, so that you know in what status they are, when do I have either to calibrate, either an automatic calibration or manual calibration. So that is all set and part of, let's say, these installations. So there's nothing that is really complicated, because most of these calibration procedures are done very automatically, and with the proper training, they can be done, let's say, with a trained personnel from your side as well.
Yeah, that's great, because you don't want that to be one of your factors you have to add into the decision process. So it's good that they're all pretty good to use.
Yeah, don't worry, because these sensors are used since decades in large petrochemical facilities. There are thousands of sensors installed when we talk about in refinery, for examples. And if this would be a burden, I can tell you, we would have here another discussion. So this is really something which is quite good manageable.
Thank you, Oliver. Thanks, Darren, for the question. I think we have time for one more. Anyone else? Can raise your hand or just unmute yourself.